equals
parentheses, tangent x, close parentheses, x 2x squared.
and we are asked to find y prime or dy over dx, correct?
So yeah,
So I have to apply natural log to both
Natural log.
sides. Yes, I have no choice.
Okay.
And then when I differentiate the left-hand side, I will get 1 over y
1 over y.
times dy over
Why
dx.
do you have to put that?
Y is a function. Y is not a variable. Y is a function. When I differentiate the function, I have to write f prime times the inner function prime.
Okay.
So this is 2x natural log tangent x plus x squared times 1 over tangent x times secant squared. Is this okay?
And that was just multiplication, right?
The product rule, correct. Yes, so the first function prime times the second function plus the first function times the second function prime. So when I differentiate log, I have 1 over tangent times the inner function prime. So now, final step, I have to multiply both sides by y because I'm solving for dy over dx, which is y, which is tangent x raised to x squared. And then I put all this. So this is 2x natural log applied to tangent x and plus x squared secant squared over tangent x. And even if we can slightly simplify it here, it's fine.
Okay. Okay. So
if you were to simplify, would you use an LCD or would you just leave?
No, I'm talking about secant squared and tangent. Don't worry about it.
what are you doing? Are you multiplying tangent x squared by the whole right side?
It's the function right here. I have to multiply both sides
Why?
by this because I'm solving for this.
Yeah, I see what you did, and then you just change it. Okay. Okay.
Can you move up a little bit real quick, please?
On both sides by y.
I see how it is now. Because y is tan x squared. That's she just multiplied that times the whole in the big brackets.
See, this stuff just seems like just algebra.
Yeah.
And this stuff is the stuff that I understand.
And is that okay?
Yeah, this is stuff I understand.
Okay.
It's just like, just to me, it's just like algebra, just algebra.
Yes, it is.
Can we continue to number 8?
Yeah.
Number 8 on test 2.
Yeah. I don't know why we're doing it.
Which number was this one?
Oh, never mind. Let's count those. Well, the C was that one. Well, there is a difficulty. 8C.
Okay, I'm ready.
I'll tell you the first. The cost in dollars of producing X units of a certain commodity is C. The function is Cx equals
C of x.
C of x
Yes.
Equals 10,000 plus 5x plus 0.01.
10,000 plus
5x plus 0.01 x squared.
0.01 x squared.
Yeah.
Okay. So we are asked to find the marginal cost, which is 5 plus 0.02x.
Yep.
And then?
And then B is find C prime of 100 and explain its meaning.
Yeah, C prime of 100 is 5 plus 2, which is $7. And it's the marginal cost is by how much it increases when I manufacture, the cost increases when I manufacture 100 units.
100, okay. Now C, so compare answer from B with the cost of producing 100 first item.
Right, so for the cost for the 101st item, that is your delta y which is C of 101 minus C of 100. So this is the cost, how much it increases the cost for producing the 101st item. So this will be the exact cost. So I have to plug it in. So after you plug it in, plus 5 times 101 plus 0.001 times 101 squared minus 10,000 plus 5 times 100 plus 0.01 times 100 squared. So when you get this number, it should be very close to 7. How much did we get?
7.01.
Okay, so it's 7.01. So instead of doing this, don't cross it out, everything is correct. Instead of doing this, and look how long it took me, and I didn't even calculate it, you gave me the final answer, we prefer this because they are so close. So this is the cost, the exact cost of manufacturing the 101st term, first unit, 101st unit. This is the approximate cost of producing the 101st unit. But it's so much easier to calculate than we do prefer to determine it like that.
Well, tax credit.
Okay, ready?
Yeah. Paper cup has the shape of a cone with height 10 centimeters and radius 3 centimeters at the top.
Height and radius, height is 10 and the radius?
Is 3.
Okay.
If water is poured into the cup at a rate of 2 centimeters cubed per second, how fast is the water level rising when the water is 5 centimeters deep?
Okay. So we have 3 here, 10 here, and we have to look. Oh, that's not what I meant. I don't want it on that side. I want to, it doesn't matter actually. I can use this side. Okay. So this is 3, this is 10. This is X, and this is Y. Okay. So I have here 2 similar triangles. They're both right triangles and they have a common angle. So they are similar triangles. So I can write proportions. X divided by 10 equals Y divided by 3.
It's another scenario. I don't know. I think it was chapter 5 or
Excuse me?
I say use the same congruent sides.
Similar triangles. They are not congruent sides. The congruent are only the angles. Two similar triangles have to have congruent angles. They don't have congruent sides. If they had congruent sides and congruent angles, they would be equal, or congruent triangles. But no, this is not what we're talking about here. So I have to determine the volume. The formula for the volume is area of the base times pi r squared times h. But I have to determine a function. So the function has to depend on the amount of water that is increasing in this cone. So right now it's empty, and then it starts filling up. So this is the level of water in the cone, in the inverted cone at a particular time. So I have to find a way of presenting this volume of water, not at the height that I know, at a height that I don't know. Okay, so I'm going to say right here, I don't know what the height is, but I have to find the volume, a formula for the volume of water at a particular height that I do not know. So obviously the height of this is x. But I have to find the relationship for y, because I cannot put y in here instead of the radius. So here's the radius, which is this radius. So I have to cross multiply, and I have that y equals 3x over 10. And this is what I need for the radius. So then the volume equals pi multiplied by 3x over 10, everything squared, times the height, which is x. So now I do have a volume or a function of x. So the volume will be, this is pi, this is 9, this is x squared, this is x, and this is 100. So it's 9 pi over 100 times x cubed. So this is a function of x alone. So I know that v prime is given in the problem as dv over dt equals 2 cubic centimeters per second. So then I differentiate, and x is a function now. X is a function. So then dv over dt, function of time, of course. So dv over dt will be 9 pi over 100 times 3 times x squared times dx over dt. Now I'm ready to put all the numbers in. I wasn't ready before.
I don't understand that stuff.
Well,
I know you differentiated it, but why didn't you differentiate 9 pi over 1?
can anyone tell us how much is 9 pi prime?
This was 0, right?
Okay. So then from here I have dv over dt, which is 27 pi over 100 times x squared times dx over dt. I'm after this.
So it's not 0?
It's a product. When I differentiate a constant times a function, I get the constant times the function prime. C times f prime is C times f prime.
That's not true. Can we go back up, please? If you said 9 pi over 100 times 3x times 3 times x squared, and then you say you're supposed to differentiate it, but you didn't do it. Like, all you did was multiply it 9 times.
Can anyone tell us how to differentiate 9 pi over 100 times x cubed? Can anyone explain how to differentiate 9 pi over 100 times x cubed?
I see it now. Just write it down since it's not the same thing. It's 27 pi.
Are we okay?
Yeah.
So then I have to find dx over dt. So this is 100 over 27 pi x squared times dv over dt. And now we are told that x was, what was the height of water in the problem? When the height of water is?
When the height of water is 10.
So then I have 100 divided by 27 pi multiplied by 100 and multiplied by dv over dt, which is 2. So these two go away. So it's 2 over 27 pi, whatever that approximates to, centimeters per second.
We got to check.
Professor Lee,
Yes.
you guys done?
Wait.
Yes, we're done with that.
Okay.
You're saying 2 over 27 pi is equals to 8 over 9 pi.
Say it again.
2 over 27 pi is equals to 8 over 9 pi.
So what was the height?
10.
You said 10, but it says 5 here. You gave me 10. When I asked you and you said 10, it says 5 centimeters deep.
You said the height. The height is 10 centimeters.
I used that. That was used. how fast is the water level rising when the water is 5 centimeters deep? I asked you what is that, and you gave me 10, so I put in 10.
That's for the height.
It's the height of the cone. I asked you for the height of the water. How deep is the water, not the height of the cone, which was used from the beginning. So since it is 5, then this should be 25, and this should be 4, so it's 8.
So it's 8 over 25.
When you simplify 25 with 100, you get 1 and you get 4 here. 4 times 2 is 8, 27 pi is 27 pi.
That's still good.
How much is the answer?
8 over 9 pi.
Yes. I see. Yeah, I have to correct that. Thank you. The volume of the cone is 1/3 of the volume of the cylinder. Since you have the solution, then you understand it's just the 1/3 in front. So if you want to correct that for me, thanks. Eric? Sorry about that.
No problem. I'm just looking over Newton's method, and I see everything, and I got my equations in the calculator now.
Okay.
But what's the first one we put in? I started with -2 as x0. Do I start with -2?
You have to find where the function changes sign.
It's between -2 and -1.
Okay, so then your interval is between -2 and -1. You can start anywhere you want as long as f prime, as long as f prime of x0 is not 0. No, you're not going to start with in between. You either start with -2 or with -1, not with something in between.
Unless it's better than 1 or something.
Well, you have to give me the function. I'm not sure.
I got the right answer. I think I punched some calculator wrong.
So can you give me the function?
Okay,
What question?
it's 2 cosine x equals -x minus 1.
Good. So then the function is 2 cosine x plus x plus 1 equals 0. So our function is 2 cosine x plus 1. F prime is -2 sine x plus 1. So then I have a function that I want to create for the graphing calculator purposes. I should call it F1.
Can we use like negative? Is that
I haven't even written anything.
No, okay.
So it's x minus 2 cosine x plus 1 over -2 sine x plus 1, and this is the function I put in the calculator. You already told me that you found that a solution exists between these two, so I'm going to start with x0 equals -2 because I know the denominator will not be 0. So when I put this in the graphing calculator, in y equals, okay, my function would be x minus, in parentheses, 2 cosine x plus x plus 1, close the parenthesis, and divided by -2 sine x plus 1. Okay, and then I go to variables, And in this function, I call the function and I plug in -2.
Wait, -2 sin x plus 1.
And then the previous entry. And I say I want to plug in the previous answer. And I get this. And then I continue. And then I get this. Is this what you wanted?
Can you start over? I don't know how to use this one.
Eric, is this what you had in mind?
I'm so sorry. Can you put it back on the sheet?
On the function, you mean?
No, yeah, I didn't. I'm sorry.
So
Okay, so that's so. That's what I got.
So you have difficulties putting
X
it in the graphing
minus
calculator, or?
X.
So let me see your y equals. Why did you put that minus in front? That's it. So now go back to, yeah. So you have to go to variables and call the variable, yes. And then punch in -2. There's the, yep.
question.
Yeah, I think you probably didn't put it in correctly. Let me take a look. So it's x minus, in parentheses, 2, cos x, plus x plus 1. And you divide by -2 sin x and plus 1. And then you go to variables, variable function, you call that, and then -2, press enter.
Does that have to do with radians or? It's not radians.
Maybe mine is not.
No, so I got the answer right on the test.
Okay, let's do it again. So my y equals is correct, so all I have now is y variables y1, and I want -2. Okay, and then the previous entry, and I want the previous answer. Yes,
Yours is right.
yes, now it is.
So what did I do? Is mine supposed to be in degrees?
No, you're fine. So
Right.
yeah, let's do it again. And then press enter. No, not there. Oops. No, we changed the function by mistake. We have to go back to the function. We changed the function by mistake.
Why?
So now okay. So now you have this. Which is correct.
Oh,
So now the second
what
entry.
did I do wrong?
You didn't do anything wrong. Okay.
Thanks.
You're welcome. Yes, go ahead.
What do I do after
So you have it correctly. You don't have parentheses. You have to have parentheses around the numerator. You have to have parentheses around the denominator.
I do
No, you don't.
not on the denominator but the numerator.
So you put parentheses around the denominator. Let me show you again the function. It has to look like this. And then you press on variables.
I can't see the function.
This calculator.
So -2 sin x.
Plus 1 has to be in parentheses.
Okay.
And then you go to variables. variables.
Did you press second?
No, that's distribution.
Okay.
And then you go to the right, and that's your variable, press enter, and then you call y1, press enter again, and in parentheses you put -2 and enter.
Wait, but mine went to it went straight to the block.
You have to go get out of there with second and quit,
Alright, so wait,
because you don't need the graph.
so let me do it again. Function, I press enter. Oh, you say parentheses -2.
Yes. And you should get this -1.3499265553.
You said parentheses. Mine isn't even coming up. Try to go.
Say it again.
7, it's not responding.
Oh, you may have a mistake somewhere here. X minus oh, so the function is here. Oh, okay. To the cosine x plus x plus 1, then divided by -2 sin x and plus 1. So now you go to variables, variable function. So get out of there. So variables, and you parentheses -2, get this, and then you call the previous entry, and on top of it put the previous entry. And continue forever with your needs.
Okay, Professor Lee,
Yes.
I just restarted it.
Okay, very good.
-2, I'm gonna enter. It's -1.
And then you have to recall second and previous entry. Second and previous entry.
Yeah, I just.
Second and previous, no, not previous answer, previous entry.
But
Yeah,
this.
but not with the minus, yeah. Yeah, and then press enter, press enter. And press enter,
But it just keeps.
press enter again, and it gives you closer and closer.
Um,
It puts in the previous answer every time you hit enter.
Wait, the domain -2 and -1, we found that out. How do we find that
In the
out?
same way we found it when you asked me the same question an hour ago. The same way.
I
forgot. What do we do again? I forgot. I'm sorry.
You plug in a table and you see the change of sign.
No,
But make sure you use don't use the
like, how did you go?
differentiated one to find
Yes.
which where it crosses the x-axis. You use the
How did you go to the How did you go? You went to independent something.
You already have it. It's already set in your calculator. You don't have to do it again.
No, so I can see where did you get the domain from? Where did you get the domain? I don't know where you got.
It's already set in your calculator. You put the function in and you plug in numbers. You already have it in the independent mode.
So I just go to the table.
Yes, yes. But you
Okay.
don't have the function put in. Do you have the function put in?
Yeah, my y equals yeah.
But that is not the function. That is the Newton's method. It's not your function.
So I have to okay.
Will I be able to use your calculator again on Tuesday? Thank you.
Absolutely.
So I have to cross out all this and put in a function.
If that's what you want to do, yeah. Anything else?
Can we remember 3 from the last test, from test 4?
Yeah. What does it say?
Well, maybe it's maybe we did go over this. Maybe I'm sorry. Okay, it's find the integral.
I want the tables what comes up, but ours, how do you get to the negative values?
Put them in.
How?
You put -5 and enter.
Well, how would I know? Like the last one, it just showed like a variety of numbers.
Then change your independent back to mode, not to ask.
Where do I go?
You go to table, second and table set. Second and table set. What you were saying?
Oh, it's just 3 on test 4.
Hey, this is confusing.
This looks like a piecewise defined function.
Yes. Yeah, we did that in class together.
We did it in class. I'm sorry.
It's okay. That is based on the fact that if you want to find the area for a function between a and b, and you have a c in the middle, then you have
Okay, I remember
that's the integral from a to b of f of x dx. This is one of the important properties that we discussed, is the integral from a to c from f of x dx plus the integral from c to b from f of x dx.
So
You can always do this, and this is what you have in that piecewise defined function. So you have right in the somewhere between 1 and 4 or 1 and 5, something like that. You have a break, which means you have to use 2 integrals because you cannot integrate a function on an interval where it doesn't exist. So that's why you have 2 different integrals.
So one would be from 1 to 4?
And the other one from 4 to 5. Yes.
4 to 5.
Yes.
So what if we all get A on the final?
Say it again.
What if we all get A on the final?
If you're going,
We have A on the final.
then I will be extremely happy. That will make very, very happy. Next question. 10 minutes.
Most of it now, it's just I just gotta keep looking at the problem.
And
Other
redo them.
tests.
And redo
Yes,
them.
really,
And exactly at least 3 times.
And
And
watch
say,
the video.
I'm still not getting this. Let me look at in the book and find 4 more problems and work with them. Yes, absolutely. Yes.
Do you mind if I stay for like an extra hour
When?
today?
I'm sorry?
Today?
Not in this room.
So,
Because I have to lock the room.
so you're leaving?
Yes.
What about like before the test? Like before the test day?
I will be here at 5 o'clock.
That's when the exam starts.
Some people come at 6 because we actually have our class starts at 6:30, so I don't expect everyone to be here at 5.
Is the test day?
Yes. Anything else? Other questions for me? Anything else? Now, if you want to practice with it or something, you can take it now.
Are you sure?
Yeah, I
You're
don't
not
have
gonna
it.
need it, like,
No,
oh, that would actually be
no,
great.
but this is not my calculator.
Yes, I know, I'm not gonna break
So just be careful because otherwise I'm liable.
it. Okay, I'm not
It's
gonna
not
break
mine, it belongs to the math department.
it. Okay, thank you so much, that actually is gonna be a big help.
My pleasure, sure.
I have a question in test 4.
Yes?
It's actually question number 1.
Okay, very good.
I thought we integrated velocity.
Yes?
The acceleration, you get velocity,
Yes?
you get distance.
Okay, next question. Anything else?
Can you do one new method for our problem? We'll fix it.
Yeah, this was one. This was exactly what we just.
Oh, okay.
This one. This was Newton's method.
Okay, never mind.
What do you guys think? Maybe one more optimization?
I mean, yeah, I'll do it, but that has to be extra credit.
Yeah.
That has to be extra credit.
Oh, can we do the well? There was two things. There's linearization and then one that went with linearization.
Differentials.
Okay, can we do a linearization?
Yeah. So, for example, let's say we have f of x equals 1 over x squared. And we want to find the linearization, which is f of x plus f prime of x times x minus a.
We did this in class.
Yeah, it's part of test two.
So it's when x equals 1.
Where you have to find x. And like,
Let's say 1 over x to make it easier.
you have to determine what x is and then like what delta x is.
Did it come to the question?
Yes. F prime of a. I'm going to just change it to 1 over x. Okay. So f prime of x equals 1 over x squared. Negative, of course. So f prime of a will be negative 1, which is 1. I'm going to put it 1. It's negative 1 over 1, so it's negative 1. So this piece is negative 1, this is 1, and f of 1 is 1. So the linearization L of x, I can write f, is 1 minus x minus 1. Or 1 minus x plus 1, so this will be negative x plus 2. This function approximates this function near, really near, x equals 1.
That's the other thing I was thinking of, approximation.
Right.
Is there a question on this? On the test?
So,
You got a number?
I don't know off the top of my head, but it should have been the second
Yeah,
test.
the
Should have been the second test. It was either linearization, it was either this or it was approximation.
yeah, like the square root, let's say, of 99.
Yeah.
Or the square root of 101.
Just to find like what x really is supposed to be, which would be like 100, and find out what the difference is. Which is
What the
-1.
function is, the derivative, the x, and the approximation, the differentials.
Oh, it's using the differentials to estimate sine 89.
Yeah.
Is that what this is?
No, you said
Oh, yeah,
linearization. You said linearization. That's why I gave you the function.
Oh, is it
This is the linear function that approximates this function when x is close to 1.
Is it something he just said use differentials to find sine or whatever? Is that the approximation?
That is the approximation using differentials.
Okay.
This is the linear. This is the function that can be used to approximate this function when x is near 1.
Okay.
Yes.
Can we do number 9 then?
What does that say?
Use differentials to estimate sine 89.
Yes. So we have sine 89 degrees, which is the same with sine 90 degrees minus 1 degree. So then the function that we are talking about is sine x. X is 90 degrees. Delta x or dx is negative 1 degree, which has to be changed into radians. So it's negative pi over 180. So then I know that sine I shouldn't write it. Let me write the general form first.
So 1 degree is pi over 80.
Yes.
Oh,
So this is approximately f of x plus f prime of x dx. So this is sine 90 degrees. This is, let me write also f prime.
Negative cosine.
So it's just positive. Yes.
I got anti-derivative.
Cosine, yes. And this is negative pi over 180. So then our sine 89 degrees is approximately sine 90, which is 1. Cosine 90 is 0. So cosine 90 is 0. 0 times this is 1. So that's it. Plus 0 if you want.
Cosine 90 is 0.
Cosine 90 is 0.
Would it be 0 times delta x and 0 times something would be
But
0?
still 0.
Oh, I thought you said it was 1. Okay, never mind.
So no, sine 90 is 1, but the rest is 0.
Okay.
Yep.
So what does this have to do with linearization? I don't understand what's going on.
The linearization has nothing to do with
This is
this.
approximation.
What do you mean?